Have you ever wanted to be a cyber detective? Well, today you're on the case. We've got a suspicious file on our hands, and our mission, should we choose to accept it, is to build a custom malware detector completely from scratch. We're going to hunt for clues, gather evidence, and create a digital wanted poster for this thing. Let's get to it. And just so you know where all our intel is coming from, this entire explainer is based on a fantastic video lesson from eLearn Security called Creating IOCs with IOC Editor. So, here's our plan of attack broken down into 5 key stages. First, a suspicious file pops up on our radar. Then, we'll gather its digital fingerprints. After that, we dive deep to uncover some hidden clues. Next, we build the digital trap itself. And finally, we'll wrap it all up in a neat little case file. All right, every good investigation has to start somewhere. Ours kicks off with a program that, just doesn't feel quite right. This is the case of the misspelled Microsoft malware. Let's get a closer look. Okay, meet our main suspect, a file named junkfilescleaner.exe. On the surface, it sounds pretty harmless, maybe even helpful. But should we trust it? Nah. From here on out, we're treating this thing as a key piece of evidence. The investigation starts now. And wow, we didn't have to look far. Right away, we've got a huge red flag. Looking at the file's properties, the company name is misspelled as Microsoft. I mean, come on. What are the chances that Microsoft would actually misspell their own name? This isn't just a simple typo. This is a massive clue. Okay, with our suspicions basically confirmed, it's time to get a little more formal. We're moving on to the next phase, collecting this file's unique identifiers. You can think of this like a forensics team, dusting for fingerprints at a crime scene. We're going to start by grabbing 3 key pieces of data. These are what we'll use to build something called an indicator of compromise, or an IOC for short. First, we calculate its MD5 hash. Second, we jot down the exact file name. And third, we record its precise file size. First up is the MD5 hash. The easiest way to think about this is as the file's unique digital fingerprint. It's a long string of characters, and in theory, no 2 different files will ever have the same one. That makes it an incredibly powerful and specific piece of evidence for our detector. Next, we've got the file name itself. Now, you might be thinking, can't an attacker just change the name? And yeah, they absolutely can. But right now, for this specific incident, junkfilescleaner.exe is part of the evidence trail, so we are definitely adding it to our list. And our third piece of basic evidence is the file size. And we need to be super precise here. It's exactly 563,200 bytes. This level of detail is really, really important when you're trying to build a detector that's accurate and doesn't create a bunch of false alarms. So we've collected all the evidence from the outside of the file, but now it's time to go deeper. We're about to look inside the file. It's time to interrogate the binary itself and see if we can find any hidden text that gives away its real, probably malicious, purpose. To do this, we'll use a neat little command line tool called strings.exe. What it does is pull out any readable text from a file. The command you see here is basically telling the computer, run the strings tool on our suspect file, and then the pipe symbol sends that output to more, which just lets us read it page by page. It's kind of like a digital X-ray for files. And, well, that didn't take long. Almost immediately, we find something really incriminating. The words key grabber are just sitting there, embedded right inside the file's code. This is a huge clue. It strongly suggests this program is actually a keylogger, designed to steal everything you type, like passwords and private messages. And the plot thickens. We also found this file path, c/system.log. Now, what could that be? It's a pretty safe bet that this is where the malware plans to stash all the data it steals. This is another crucial piece of evidence for our case file. And here it is, the smoking gun. That same misspelling, Microsoft, that we saw on the outside, it's also written into the file's code on the inside. This is what connects the external properties to its internal workings. It totally confirms our suspicions. This is what we were looking for. Okay, investigator, we have gathered all of our evidence. The clues are on the table. Now it's time to actually build our trap. We're going to use a tool called the IOC editor to assemble all these clues into one single functional detection rule, a rule that can hunt for this malware anywhere on a network. The process itself is actually pretty straightforward. For each piece of evidence we found, we're just going to add it as an item into the editor. We'll paste in the specific value we found, like the MD5 hash, and then we connect them using some simple logic, either and or. Then we just rinse and repeat for all our clues. Now, understanding this logic is absolutely key. Think of it like this. If you use AND, it means a file has to match all of the conditions. It's super strict. If you use OR, a file only needs to match at least one of the conditions. This makes our trap way more flexible and a lot harder for the malware to wiggle its way out of. So how does this all come together? Let's look at our final rule. Our detector is going to flag a file if its MD5 hash is an exact match, or its file name is junkfilescleaner.exe, and its file size is exactly 563,200 bytes, or if the file contains the string Microsoft. See how that works? We've just created a very specific and very effective digital wanted poster. We are so close to being done, but a good detective always leaves detailed notes, right? We need to add some context to our IOCs so that anyone else who finds it later knows the story behind this threat. This is how we build a complete and useful case file. So we'll give it a clear name, a quick description of what it is and where we found it, we'll credit the author, that's us, and classify it as a keylogger. This extra info, this metadata, is vital. It's what turns a simple list of technical data into actual, actionable threat intelligence that can be shared with the whole security community. And that's a wrap. Our indicator of compromise is complete, it's saved, and it's ready to be deployed. We've successfully taken a single suspicious file and turned it into a digital tripwire that can help protect an entire network. Case closed. But that leaves us with one final thought to chew on. We built a pretty good trap based on some fairly obvious clues, right? But what else could we have looked for? What other digital breadcrumbs might a piece of malware like this leave behind that could have made our detector even smarter, even more powerful? Hey, if you had fun playing Cyber Detective with us today and you learned something new, hitting that subscribe button and giving this a like is a massive help. It really lets us know you found this valuable and helps us keep creating more explainers just like this one. Thanks for watching.